Hi, and welcome to my session here at Pulsar Summit Asia 2021, despite the current date may be. I'm Tim Span. Today, we're going to be talking about using what I call the FLiPN stack for Edge AI. So it's using a combination of Flink, NiFi, and of course, Pulsar. Helping me set this up, and hopefully when we're broadcasting live, we'll have a chat with David, who's done some great work on Pulsar and has built the NiFi Pulsar connector, which is very important for our FLiPN stack, because without that, we're just Flip, which is still a good stack. But NiFi really helps round out a number of use cases, especially around gateway, getting data on board, adding extra sources, lots of fun stuff here. All the links you might need to contact us, see some source code, see articles, all those sort of things, promote David's awesome book are available here, and we'll make sure those are shared throughout the event. So what is a flip stack or a FLiPN stack? I kind of leave this a little open because sometimes you just need Flink and Pulsar. Sometimes you need Flink, Pulsar, and NiFi. Lots of different technologies around it. Pulsar always in the middle. Make sure that you can have your data available anywhere, transmit it, geo-replicate it, have it in a stable place where you can query it, use it whatever means necessary, have tons of different consumers, producers. It is the great way to be able to do this. So I'm very happy that that's part of this stack. And my favorite three languages for developing apps when I'm not using something like NiFi, Java, Python, and Go are really easy to work within this stack. Great way to get data onboarded into Pulsar or maybe pull it out for applications. Lots of great things here. Obviously, you could use other languages or perhaps none if you want to stick with NiFi, but certainly you could use Scala, Kotlin, and hundreds of other different languages here. Lots of different connectors for different languages out there. Now, a lot of the demos today I'm going to be doing using Stream Native Cloud. To be open, I work for Stream Native, so I kind of love it. But having something powered by Apache Pulsar and having this cloud native place to do your messaging and streaming and doing that really easy, having that scale out, have our Flink SQL in there, makes it a very logical place for doing Flip and FLiPN apps. So I mentioned NiFi. If you've seen some of my talks at ApacheCon or just searched Twitter, you might have seen my face with NiFi. Kind of a big fan of NiFi. I wrote a couple of processors for it. It is a very interesting open source tool that's been around for a number of years. It is not like Flink or Spark, and it's not like Pulsar. It's kind of a unique tool. I think of it as a Swiss Army knife. It's got every possible thing you want, maybe not always the best thing to use for every use case, but it can get you started, get you prototyped, and then you figure out, okay, is this the right tool for it? Often it's a very key part of the first part of an application, maybe grabbing data from REST, grabbing different pieces of data from logs, transmitting them, converting them, routing them, doing lots of things there in a very easy to use way. It's very scalable despite the fact that it's graphical and easy to use. You get things that you need when you're going to be doing things with real-time streaming and real-time event processing. So it fits in with Pulsar, Flink, Spark, and all of our powerful friends out there. Because you get that guaranteed delivery, you get data buffering that's adjustable and configurable, either from a command line or from a REST endpoint or through the UI. Very easy to adjust for every single point where you touch data. You want back pressure, how much, how you're going to release pressure, all those sort of things. Be able to set priority on every step of a data flow. Very nice. Data provenance. This is helpful because we're collecting data from everywhere. Different cloud zones, different applications, devices, different ways, different apps. Sometimes it's Java, sometimes it's Python, sometimes it's Golang, Kotlin, Scala, JavaScript, Node.js, lots of options there. once I get it into NiFi, it's very easy for me to track the provenance of where that data came from, all different valuable metadata there and metadata that I can add to and enhance. So I know what's going on with my data. How did it change from where it was born to where I'm finally going to have it permanently live? Lots of things there, lots of different sources and syncs there. Very easy to use, very secure, built-in version control clustering, all these things that you need for a tool, whether you consider it for integration or ETL, ELT, something to onboard data. And fortunately, thanks to David's work over the years, including some very recent upgrades. So if you haven't seen the Pulsar connector for NiFi out there, please check it out. We're going to put that into an official directory soon, but David has it in his repo. Please download it, evaluate it, test it, give him some feedback, suggestions. You know, it's in GitHub, do a pull request, whatever you need to do there. There's a pre-built NAR file there, so you can just download it. There's a couple versions out there. I've done things with 111, 114. You could use it all the way up to the latest version of NiFi 115, regardless of where it's deployed. Talking to my friends at Cloudera, see we get this deployed out to some different Kubernetes environments and different clouds, give you different options of how you have this hosted, but pretty straightforward NiFi processor that's runs really well. I've been enjoying it and very happy to have David develop this so I can use this for my applications. I've got a couple of articles out there. This one shows you the real basics of pull the processor onto the screen, set those parameters, and connect to your Pulsar cluster. Now, regardless if that's a standalone one, you just put on your desktop, put one in a VM using Stream Natives, no matter what kind of security, all that's set up for you, set up to make sure it handles when connections go up and down. Very stable, very fast to move your data through. It is a nice way to do this. And like I said, there's a couple of different options here, different versions. I've been trying a bunch of them. I recommend you get the latest release 114 or compile it yourself. It's just a Java app, really easy to do. Having talked to some of the important committers at the Apache NiFi project, they told me, make sure you use the record one. We're probably going to deprecate the non-record processor there, so you really don't need them. It's a really good idea to use the record processors. It's fast. It's the standard for NiFi and can pull out whatever format you want. This works out really well because Pulsar has its own schema registry. So you can make sure you have valid data, whether it's JSON or Avro, both things NiFi supports. Protobuf, we'll have to look at that in the future. Pulsar has it. We haven't added it to NiFi yet. I do have a test processor out there. Something to think about. NiFi also supports CSV and Parquet, a bunch of other different record formats. So you can play around with which ones make sense. You know, transmit it through Pulsar in the format you want. Let NiFi automatically convert that to something else, depending on your use case. I'm going to drop this in Databricks, and I need that to be in, say, Parquet or CSV because the data scientist is going to work on it. And it comes natively out of JSON or out of a log. No problem. The combination of Pulsar and NiFi, we've got you handled, got everything converted, ready to go. Now, to connect two things, pretty straightforward. If you've used Pulsar, which I'm assuming you might have at this point, hopefully this isn't the first time you've seen Pulsar. You're probably at the wrong conference, but welcome. It's a good time to start learning. Pulsar is awesome. So you put in your service URL. Again, if you're using Stream Native Cloud, SSL in there, you know, different ports, different places, depending on the type. For this one, we're using OAuth, pretty easy to set up. That's separate from my controller. The controller is sort of like a connection pool, manages, you know, making sure things are kept alive, how many classes there, all those sort of things you expect. Lots of different parameters to tweak for, depending on how much performance you want coming through. Again, sometimes depending on how much data you have, how much you paid for your environment, you may want to tone down how many requests you try to process at once. I have taken down some services before. This is something you want to tweak there, or talk to the people at Stream Native to help you determine the optimal properties there. So once I'm going to log in, this is one way. This is how I did it. This works for me. So I have a file in a secure environment. I downloaded this from my Stream Native cloud, put in the issuer URL, set that audience, and we're set to go. I don't have to worry about passwords, losing all that. It's right there for me. And again, there's a direct link to download the NiFi connector as a NAR file, which is just NiFi's version of a jar file with some extra metadata there. It's a nice standard format. That name might sound familiar because Pulsar uses that as well. Great idea, and it works very well for Java. So once I've pushed data to, say, my Pulsar cluster, very easy to check out that data once it's in a topic. Within Stream Native, I can just navigate to my topics and start browsing the data. As you can see, I passed it in as JSON, pretty standard format there, easy to handle. Since it's in JSON or Avro, something to think about. I want to set a schema. That's something you could do from most of the clients. Get things in a schema. Use the Pulsar schema registry. Highly recommend it. It's very easy to see what's going on if you use the one that comes through Stream Native. So you could easily see what version you're on and look at the schema without having to make a couple of command line calls, whatever. So now that I have it, it's in a format, it looks like a table. Well, guess the advantage of having something look at like a table. If it looks like a table, it's formatted like a table. I know the field names, I know the field types, I know if they're nullable. Makes it very easy for me to run SQL against it. Now, if you've been using Pulsar, obviously Pulsar SQL with Presto Trino is great. I love it. I'm running that right now. It is a great way to quickly get to the data in my topics. Whatever is there, get it back, got my results, can do what I want with it, displayed in different tools, put it in a dashboard. That's great. The issue is that is not always, when I want the data. I may want the data constantly. What do you have right now? What am I going to have in this 5 minutes of time? I want to be able to run a query against the data as soon as it's in a topic. Event is born. This could be very important. This could be a fraudulent credit card transaction. This could be some situation going on. My device is overheating. A train has a problem. The ATM is low on paper. There's things going on in the real world at event time. It just happened. I need to know now. I can't wait till I decide to run a query, or I've got some batch report running or something scheduled. I need to know as it happens. And I may need to look at, a range of a window of data over a period of time to see what's going on, do aggregates, calculate what's going on, maybe run machine learning. Fortunately, there is a project outside of Pulsar that does that pretty amazing. And there's a great supported connector out there. It gets me in and out of Pulsar with Apache Flink. If you haven't seen Flink, definitely go to their project, download it, run it through Stream Native, run it through Docker. It is a really nice engine. Java, Scala, Python, write your apps. But for what I'm talking about for the FLiPN stack, there's a very certain feature it has that makes it awesome for doing things for apps, especially if I don't want to code much. FLiPN's not about writing too much FLiPN code. I want to write a query, have a graphical thing going on, do something here, do something there. I don't want to have to write an app for every single piece of data comes in my system. I have a lot of devices here. There's a lot of different types of data. I want to try new sensors. I want to try new fields. I don't want to have to rebuild and redeploy things everywhere. Flink makes this great. This unified engine does a lot of different things. It is, to me, Flink and Pulsar are the best combination. And the combination that really kills it for these apps is Flink SQL. I could do continuous queries on the data in the topics as it arrives. And I can use that for ETL or ELT, however you want to call it. It's, I'm constantly manipulating the data as it comes into the topic with SQL. Makes you do some pretty cool event processing here, pretty easy. Flink, like most tools out there, use the awesome project Apache Calcite for really powerful, rich SQL. So I could do some really complex SQL, join together topics, limit them, order by, all the things you might want to do in a query, but against your data as it's coming through the system. Maybe it's event at a time. Maybe you're doing aggregates to see what happened in a window of a minute, 5 minutes, and then you can make decisions right away, push things right into a topic, and have people consuming that topic to know, hey, this is a fraud event. Do something now, trigger something, send a message, restart something, shut something down, react right when it happens, not every minute, not in some micro batch, not on a cron job, not when someone thinks about it, when it happens. Flink SQL is awesome for that. And you don't need to spend all your resources trying to figure out how to write and deploy these apps. And scales, it's the same story as with Pulsar. Scales as big as you need it to be. The Squirrel and the Pulsar, this is the future of writing these complex apps. And I know a number of our large company users out there, especially in your part of the world, are doing some amazing stuff. So yeah, don't forget the Flink when you add it here. There's some number of articles. This is production ready. Very good way to do this. It's a great combination with Pulsar, easy to offload the data. So you don't have to get rid of the batch. You just don't have to think about it. Treat all data as a stream, have it offload either from Pulsar and or Flink, and have Flink SQL working on this data continuously. Have syncs come out to go some places, have Flink send it somewhere else. Great set of options how you do your data. And with Pulsar, it's nice. We give additional features to Flink, so it can be data coming in a stream from Pulsar or from Kafka or from AMQP or MQTT or WebSockets. Lots of different ways we get data into the stream, into topics. So these events are available continuously to be processed at as fast as you need to be with Flink. So great combination there. Let's do some demo. Hopefully all of my things haven't timed out. I've been talking perhaps too much. It's a little easier to judge when you're out there in the crowd and get to see people and see them checking their watch and say, okay, maybe it's time for a demo. Show them how this actually works. We're going to do that. Everything you see here, I have links to every bit of source code, more than you'll ever want. Whether it's Python, Java, NiFi, scripts to start things, how I set up the topics, all of that is out there. There's a bunch of links there. But if you go to my GitHub at tspanhw, I've got a link to a lot of articles and demos and source code, all the things you're going to need there. So let's pop out of our friendly slides and see if things are working. It's not a given there. Stay back in demo time. Okay, so I have a reader running here. So something to show you, can I run things at the edge? Well, perhaps I'm running more at the edge than I should, but I've got a pretty big edge. I've got a really nice device thanks to NVIDIA. It's an NVIDIA Xavier NX, really powerful. So I'm running edge sensor readings. I'm running deep learning app with a live webcam. I'm running Pulsar. I'm running Pulsar SQL, and I'm running NiFi on this edge box. And I'm querying it right now as well. So it's pretty awesome what you could do here, and pretty straightforward. Obviously, you know how powerful Pulsar SQL is. We could pretty much do the same things within Flink. I just wanted to show you that we don't have to give this up to have Flink as well. So I have a number of data sources, and I'm using Stream Native Cloud to visualize them. So let's get those data producers running. So as you can see here, here's some of the records. I like to put extra data into my into my records when I'm coming from IoT to know some things that are useful for me. You can pull them out when you're doing your Flink SQL and say, okay, maybe I don't want those later. Like here, I've got a unique ID I generate at the edge. Always a good idea. I've got here what camera I'm using, what's the IP address, how much time it took on the network, all those sort of metadata about the machine, how much memory, how much disk space is left. This lets me run some analytics on my devices. And maybe the person who's using my application doesn't care about that. But I care about that. If one of my 500 devices is down, that's important to me. If it's running out of space, if it's running too hot, things I have to think about, and with bandwidth today and with the power of Pulsar, not too concerned about adding a couple extra fields here. If that's a concern, I could always pull down a couple of them. But here I've got my deep learning information here. What did it think it saw? What it was, percent. And I actually have a link to the image. And with NiFi, I could pull those images off the devices or use NiFi, a sub-project, and get that data into a different type of stream. I don't recommend streaming images through Pulsar. There's not really good use case there, but having that metadata, that's important. So we have that traveling through, and I could see that in Stream Native. Now I could run a query with Flink against this data pretty easily. If you're doing this on your own, you could set up a Docker and set up where you're going to have your connection between Flink and Pulsar. It is pretty straightforward, but it does take a little work and you're not getting a nice graphical environment. But this is pretty much how we do it. All these are set up just like it is in Pulsar. I have my tenant, my namespace topic, boom, connects that as a catalog in Flink SQL, and I just read from the tables. Of course, these tables have to have a schema in Pulsar. Otherwise, you're not going to know how to set up that data, especially if it's just a set of bytes. Now, you can create your table manually if you don't have that catalog connection there. As long as you have that connection between Pulsar and Flink, you'll be fine. But again, having someone else do it for you is nice. So we have data running. Let's make sure we have that data being built. Here is that same device. And I'm going to run my, okay, let's show you behind the scenes. Oh, you have the source code, but I'm going to show it to you. This is based on some code that NVIDIA gives to you, plus it does all the deep learning. Plus, I like to add all those extra fields, my unique ID and all that metadata you saw. I write it to a log file. I also send this right into an MQTT queue. But if you're looking at the name of the topic in MQTT, this is not a standard MQTT topic there. Obviously, that's a Pulsar topic. I'm using MOP MQTT on Pulsar to make Pulsar act as it, because sometimes in IoT, these devices always want to push to MQTT, and rewriting stuff to put in a Pulsar connector. Maybe it's not available for your hardware. Maybe it's not available for the language you like, or it doesn't run the way that you want. So this gives you an option. Just send it there. Again, I could have something reading off the system as well. And just to show you, there's multiple ways to do it. My script is not pretty. I probably don't recommend this for production, but I'll show you what I'm doing here. I have an infinite loop. I grab a date format, call my Python script with a couple parameters telling me what deep learning to use, where's the image, and that's about it. And then after that, I run a Java app that knows what the schemas are, how to use them, and connects to the local Pulsar. And if I want, I can have that replicate up to the one I have in Stream Native. Lots of options here. So I'm just going to run that so we get some data into the system. And it's running deep learning on a camera somewhere over there. Maybe it's going to get my head in there. It's probably going to think it's the moon. What are you going to do? I don't always get good results when it takes a picture of me in deep learning and it's running sewing machine. Yeah, I think I have another NVIDIA device in front of the camera. I should probably point it outside. I've got a 12-foot skeleton out there. Maybe it's a little more interesting, but we'll use what we can here. Let's see if we have anything else we need to run. Yeah, that's an energy app. Maybe we'll run that too. I've got, that's another device. I've got a lot of things running here. This is running sensors on a different Jetson device. I kind of like those. Here to show you what you can do if you do want to write code. And I'm not a Golang expert at all, but using the example code, it was very easy to write a Golang app to send Pulsar data extremely fast. I'm very impressed with the performance of Golang. I'm probably going to use this for a lot of apps going forward because the speed of this little app to read from a log file, iterate through it, and send a Pulsar message is impressive. This is this IoT producer, and I have this compiled here, and I'm just going to have a shell run it. Let's make sure we run the right one. Just send this to the local one, or we could send it to the one we saw on Stream Native, and I could show you how fast they run when we do that. And a few seconds to connect to the remote broker and log in, and now it's streaming data very fast. The local one doesn't have that login because it's right on that same box. And you can sort of see the number incrementing as we're hitting over 1,000 records. And it's slowed down because I'm printing it out to the screen. It would be even faster without that. So if you do want to pick a language to write, this is Golang on an NVIDIA box, and the performance is very impressive. Just to give you an idea how we can process things. And we get that data here. We can run a query for Flink to see that next part. Now I have NiFi. I usually lead with NiFi, but I wanted to show you getting some data into the system first. Let's see which one we're reading. This is that processor I showed you. It's going to assume JSON records are coming in. Keep them at JSON, but if we wanted to change them to something else, which is perfectly reasonable, Avro, CSV, influx protocol, Parquet, XML. I don't know why you'd want to output XML. You could. Here's our connection to that Pulsar I mentioned. Pretty straightforward to connect to it. And, this one's connected to the local one, so I don't have to have any authentication. This is behind a firewall. Don't worry about it. But in the real world, you're going to want to keep that in a secure environment and not let anyone just access it, just to give you an idea there. I've got a lot of different sources of data here that we're getting in NiFi. But before I get in front of myself, I want to show you a little bit why I like NiFi. So you see here, very easy to use environment. If I want to add extra processing, it's drag and drop. You can see here the Pulsar connections there. We've got the same for Kafka and MQTT, and for TCP/IP and databases and SQL and NoSQL and Mongo and AWS and all those sort of things you might want to connect to. Here I could start and stop things on demand. And in between, I have this adjustable little queue here. And as data comes in, I could send it to a processor to be processed. Here, as you saw, we got a failure. Curious what that is. And we could take a look at that. That's sitting in a local NiFi queue. This is not in Pulsar. We pulled it out of Pulsar to do some processing here. Maybe I'm pushing it to Solar, wherever I happen to be doing. This one got queried from NiFi, again, using Calcite. And this is giving me an alert if the voltage is over 117. If that happens, I want to do some additional processing. Maybe I'm sending this to someplace that processes those. Maybe it's going to a Slack channel. NiFi has a lot of connectors. I could send out a Slack, could send out an email. I've got a way to send out to Discord. You have different options there, pretty easy to handle. And I could just stop things when I'm not processing anymore. And they could just sit in this configurable queue. And I could see my data. See, some of the data has been sitting there for almost a week, and it's not a problem. These are stored in disk. So no worry about losing the data, but all the metadata is there, all the actual data. And if I want to redirect that data somewhere else, say I just want to drop it in a file system, I could just connect it here and literally drag that live data from where it was going to somewhere else. And then just have it push there, and then have a new connector go there, and have no worries there. I can send data to as many places as it needs to go. Pretty straightforward. Let's see if this one loads. Here I'm looking at the status for a number of different cloud providers. They happen to be using RSS, which is using some of the dreaded XML, but it still works. It is a good way to do it. And it's very easy for me to process with NiFi. And once I get that data coming into the system, I can do a couple of interesting things here. I'm using that URL, calling a REST endpoint, any REST endpoint you want. Here, I turn that RSS into JSON, split it out into individual links, grab a field that I'm interested in, and here I'm doing a query on that based on what the message is. And then I'm sending it to a Slack channel. I've got that Slack channel over here, and I could see some local transit information. Obviously, you connect this to whatever feed you have, whether it's RSS, XML, JSON, Avro, transit protobuf, which I have a processor for. And this is a very easy way for me to tell the people at work, hey, the bus is late, without having to write any kind of super complex application for it. That was just using what's in here. This one, I can start sending more messages. I have them paused like you saw before. And then I have a timer on there, because if I send too many messages to Slack at once, I get in trouble. So I don't want to do that. So we'll just keep getting messages there as they come in different channels based on where the data is, just to give you an idea there, how we're doing different things with different data, whether it's from transit data, whether it's from IoT data, whether it's from energy data. Doesn't really make a difference. Pretty easy to work with it wherever it is. So let's get back to a couple more slides before we show a little more on demos. I think I have a little bit of time left here. So we did an example FLiPN Edge AI app. And, we have Flink in there to do some continuous analytics, to look for fraud, maybe look for deterioration of devices. Those are pictures of some of the devices I have data coming in, and some of them are using different ways to get into the Pulsar cluster, whether that's NiFi's helping, whether they're going directly through Pulsar, whether they're going through the WebSocket UI, whether they're going MQTT, even the Kafka protocol, whatever one you might have in place already. We get that into Pulsar. Pulsar has a couple of syncs dropping that over to my Aerospike database and my ScyllaDB and Trino. And then I have some of it being offloaded to some cloud tiered storage. Well, at the same time, those events are being consumed by Flink in order, perhaps exactly once, doing some continuous SQL there, sending some output to different topics, lets you run those continuous apps there. There's some interesting projects that let you connect to Flink SQL from different things like Zeppelin or Jupyter. So watch that space for some interesting applications in real time on top of Pulsar topics. Pretty cool. And again, you've seen the different Pulsar syncs out there. Stream Native Hub has a nice list there. We can easily stream that data to a ton of different places. And again, the fact that it was edge apps didn't really matter. The nice thing with the tools we use today are, I ran all this on the edge node, and NVIDIA has some bigger ones, and there's also some other brands out there You put something with 16 gig of RAM, that's not a lot, and a couple cores, and you could easily run a small Pulsar node to geo-replicate that data out for you, or however you want to do that. But it's nice. I can bring Pulsar, NiFi all the way down to the edge, even do deep learning and machine learning with them, spread that data up. Maybe once it gets up to the main cluster in a cloud, I can run additional Pulsar functions that are doing things like machine learning. David has a nice talk for that. If you want to take a look at that one, is on YouTube. Pretty cool stuff. Got a lot of articles on different pieces of the stack, whether it's NiFi. Again, I did NiFi for a number of years before I realized the power of Pulsar. There's links here for Flink, links here to other talks I've done this year, last year, previous years. So if you see something you're interested in, you could look at some other ones, work your way down there. If you need to know more about Pulsar, we've got some great on-demand classes here. It's really good quality stuff. Start right away. Very easy way to get started on your own schedule, on your own time. Just log into the URL. Very easy to use. Nice way to start learning. If you're really into this stuff, got some Flink, Spark, or Pulsar, we are looking for people worldwide. So check out the URL. We definitely need some more people. I'm assuming everyone here knows about the Pulsar Slack and Twitter. So I don't think I need to tell you about that one. I've got links to some Flink SQL resources. And as you already know, we have 2 cool books out there. Coming up soon, a virtual event for ScyllaDB. I'll be doing a talk on Pulsar and ScyllaDB. Nice combination there. Pulsar really works with everything, so that's really great. Stay in touch with me. Whether it's async or sync, I'm usually around. I'm very interested in showing people different apps I have, regardless of what that app is. If you have some ideas for other applications, please let me know. I'm always looking for a fun thing to do. If you come into my other talk, I don't know which one's first, but I'm sure you can see them on demand. I will be showing you a little app that I'm working on that's doing web sockets and a web front end to move data around. It's kind of interesting, I think. So stay tuned. I hope you liked my talk. I hope you, start looking into the Flip stack, contribute. I'm definitely looking for more ideas, more apps. If there's more pieces you think we could fit in there, they got to have FLiP or one of those other letters in there. The S in stack could be for Spark, TensorFlow, lots of options there. A could be for any Apache project. So we've got that pretty open there. There's a lot of great other projects out there like OpenNLP, like Tika, lots of great projects out there. So thanks for joining me. I hope my New Jersey accent wasn't too hard to understand. Next time, someone should probably dub my voice into text so people can see what I'm saying. But thank you and enjoy the rest of the conference.